A drawing must only be interpreted one way. Creating and reading drawings so that interpretation is clear means that a certain set of rules, standards, symbols, they must be understood and they must be followed by everyone. To illustrate this, think about how important driving laws are. Imagine if governmental laws for driving a car were not clear, if they weren't absolute. How many more accidents would there be? So the same is true for interpreting technical drawings. There are rules for reading an engineered drawing so that there is only one interpretation. Understanding these rules and following them guarantees that this part can be made in any machine shop with the same results. More importantly, if your shop is making one component of a machine while another company is making its mating part, how important having a set of standards would be so that those parts, when they come together, mate properly and that mechanism or machine functions properly when assembled. To ensure that prints are only able to be interpreted one way, most countries set up a standards committee responsible for agreeing on and setting a set of rules and standards to control how prints are generated and how they're interpreted. In Canada, drawing standards are established by the Canadian Standards Association, the CSA. All engineering drawing instruction in these courses will be based on the CSA standards. One of the first things we need to know regarding drawing standards is how to look at a print. A three-dimensional part needs to be described by way of different views on a two-dimensional plane. Therefore, a three-dimensional object or part is described by a method called orthographic projection. Look at this part here. This part will be manufactured on a milling machine. It will be a three-dimensional part. But my computer screen and my printer paper that this part drawing will be printed on are only two-dimensional. Therefore, I have to be very clear on what this part looks like from all sides, as well as any internal features. It is important then that the views we use to describe the finished part be clear and easy to interpret. There are two systems of arranging views to describe a part. We are only going to consider third angle projection. Like first angle projection, third angle projection is a way of positioning views. And now typically, only three views of an object are required to accurately describe the shape of that object. Those three views are the top view, the front view, and the right side view. The front view is the main view. It is the view that describes the part the best or provides the most information about the part. It is up to the engineer to decide which view is the front view. Once the front view is established, all other views are positioned around the front view in their proper position relative to the front view. Please, again, look at this object, this part that we're going to manufacture. You are currently looking at the front view. Therefore, the top view of the part would be here. It is on top of the front view. It is the top relative to the front view. If we rotate this direction, we are now looking at the right side view. It is on the right side of the front view, or it is the right side relative to the front view. These are the three main views of orthographic projection. By way of review, drawing standards in Canada are set by the CSA, the Canadian Standards Association. Orthographic projection uses three standard views, the front, the top, and the right side, to describe a three-dimensional part in two-dimensional space. The front view is the main view. Once the front view is decided upon, all other views are positioned around the front view relative to that main view. Thank you for joining us. We look forward to seeing you in our next video, where we continue a consideration of drawing standards.